let's try to solve another Leetcode problem 1340 and jump game 5. So for this problem, I think the difficult part is how to understand the problem. So after understand it, you're gonna turn this problem into a easy pattern, and then you're gonna use the easy pattern to solve the problem. So let's first try to understand it. So we are giving an array of integer array at an integer d. So in one step, you can jump from an index I to index I plus 1 and I minus 1. So this I plus 1 should less than the length of the array. Yeah. And this I plus x should less than the length of the array, and x should be more than 0 and less than equal to d. So what does this mean? Yeah, normally if we are given such kind of formula, we need to understand what is the meaning. So I minus x, where I minus x should be more than equal to 0, and this x should be more than 0, less than equal to d. Yeah, so let's just use an example, try to understand those two descriptions. So let's just use this example, d equals to 2, and what does this mean? Yeah, so this means we can jump from a person to another person if it meets the formula 1 or formula 2. Yeah, so if we don't have this constraints, we just have those above two descriptions. What we can do? Yeah. So for example, we are at person 13 at this person. So we can jump d steps to the right or to the left. This means we can jump from the highest place index 5 to index 7, or we can jump from index 5 to 6, or 4, or 5 to 3. Yeah. So this is our range. But now we have another condition. Let's just check the condition. So our another condition is that you can only jump from index I to index j if array I more than array j. So this is more interesting. So this means, for example, we are at index 10. We can only jump from index 10 to index 8 or index 9. That is okay, because this person is higher than the next person. So the index 10 is higher than index 8, it is higher than index 9, it is okay. But we want to jump to index 8, because this is also inside of the range, so the range is d. Yeah, so this is one step, this is another step, but we cannot jump 3 steps, because d is equal to d equals to 2. Yeah, we can at most jump 2 steps. Yeah, so this is the meaning. And now let's just try to understand another one. Maybe some of you don't understand this one. So if array I more than array j and array I more than array k for all indices k between I and j, more formally, the minimum of I and j should be less than k and less than maximum of I and j. Yeah, so what does this mean? So this means, for example, if we were to jump from this position index 10 to index 8, it is okay. But what if this index 9 is higher? Yeah, so let's just use another color. So maybe this is higher. Yeah, so this is maybe 15. Can we jump from this position to 10? No, we cannot. We can jump from this index 10 to index 8 only if something in between, this is this index k, should be this position should less than and equal to index 10 and less than, more than and equal to index 8. So this is the only condition. We have to meet such kind of condition. So this is like that. Yeah. So currently, if we understand all about it, we're gonna use a trick to solve the problem. Normally, this is gonna be really difficult if we directly use dynamic programming. Yeah, because there's nearly no patterns we can find. But we're gonna turn this problem into an easy pattern. So the pattern gonna be a graph. We can loop through the index one by one, and we can build a graph. How can we build a graph? Just according to those descriptions, definitely we can build a graph. So this is two descriptions, this is another description. According to those 3 descriptions, definitely we can build a graph. If we can build a graph, the problem becomes easier. So let me use another color. So if we can build a graph, so this is our graph, and I just drawn a random graph. So what we are going to do, if we can build a graph like this, definitely we are going to calculate the longest path of the graph. So for example, this is the longest path, 1, 2, 3, 4, 5. So the answer is going to be 5, because from here, 1, 2, 3, 4, it's not the longest. But how can we build such a graph? So we can build it by two loops. So the first loop, we're gonna loop through each of the index. Yeah. And then for each of the index, we're gonna check the left side, check the right side and the left side to build the graph. If we can build a graph, the problem is gonna become much easier to solve. Yeah. Now we're gonna use build a graph. So let me just use an example. So for example, we are going to build a graph from index 10. How can we build it? Yeah. So for this index 10, so we're gonna use this is a k, and all the value will be inside an array. So first of all, to the right side, there's nothing to the right side. So what about the left side? How many indexes we can put inside? So 1, 2, 3. We can jump to this index. I'm sorry, 2. We can jump to this index 9, or we can jump to index 8. So this means inside the array, it's gonna be index of 9 and 8. Yeah. So yeah, let me just clear it a little bit. So this is the index 10, and inside we have the array. It's gonna be index 9 and 8. Yeah. So now let's just try another one. Let's just try this index 8, right? So for this index 8, we're gonna continue to build our graph. So which index we can put inside? We can put index, so for example 9 here, and this index 7, it is okay, and this index 6, it is also okay, because it is still inside of the range of 2. Yeah. So this is for index 8. So we jump from this 10 to 8. So currently this is 10, this is 8. From this index 8, we're gonna jump to 7. So this is 10 to 8, and this is 8 to 7. And then let's just check this index 7. So for this index 7, we're gonna continue to build the graph. So inside it's gonna be index 9. Yeah, right. Now we're gonna find this index 9. So this is gonna be index 9, and the height is just 6. And from here, there's nothing inside of the array. Yeah. So this means if there's nothing inside, definitely we cannot go through the DFS while we are searching for the longest path. Yeah. So what is the longest path? From 9 to 8 to 7, 9, 8, 7. Yeah, did I do something wrong? 10 to 8, 10 to index 10 to index 8 to index 7, and to index 9. So what is the longest path? Because after index 9 it is nothing. So the longest path is going to be 4. So we're going to return this 4. Yeah. Now I hope you understand it, and we just use this kind of method to finish the programming. Actually, the coding would be much easier than you think if we are going to use a graph. So we're going to use default dict as always. So inside I'm going to use a list. So now I'm going to use 2 loops to build the graph. So I'm going to do some preparations. So the length of the array is going to be n. So for I in range n, and then first of all I'm going to go to the right side. So for j in range I plus 1 to n, and then I'm going to go to the left side. So for j in range I minus 1, minus 1, and minus 1. Yeah. So now let's first go to the right side, and let's just have a check. So the condition is that we're going to use if check. So if array j less than array I, and the distance of yeah, let's just use I minus j because it is the same. Yeah, less than or equal to d. So what are we gonna do? We're gonna build the graph. So di gonna append this index j. So what if else? So else, if it does not meet the condition, we can break it immediately, because definitely after that it is not possible. Now let's just copy some code here. So actually it is the same. If it meets the condition, we're gonna just append it. Otherwise we're gonna break. Yeah. Now let's just check what is our graph, because if we know the graph, normally we should know the answer. So now let's check what is inside the graph. So for example, in example 1, what is the graph? So from 0, we can go to index 1. It is okay. Let's just check another one. For index 2, it can go to index 3, 4, 0, 1, 3, 4, 0, 1, 1, 0. It is okay. So this is our graph. Now we're gonna use the graph to solve the problem. So let me just use cas, because definitely this is a DFS with memorization, otherwise we cannot solve it, right? So I is the index, I'm gonna give a pass. Yeah, so my final result gonna be 0. So for I in range n, I'm gonna check the final result. It's gonna be the maximum of the result with DFS with this index I. Yeah, so I'm gonna loop through each one of the index and check all of them, because this length of the array is only 1000. So the time complexity gonna be 1000 times 1000 n squared. It is okay. So if the length of the array is 10,000, definitely it will not work. But it is just 1000. This means we can use this kind of method to solve the problem. I mean, we can build a graph and then use DFS to solve the problem, right? So this is our result. Now we just need to finish the DFS. Actually, the DFS would be much easier. Yeah. So let's just use a loop. So for j in gi, let me just prepare a result. Gonna be starting from 1, because if we find an index starting from 1 index, so it's gonna be have a length of at least 1. So this is why the result gonna be 1. Now we're gonna check the maximum result. It's gonna be the result with 1 plus the DFS go to the next position, which is gonna be j. So finally we're gonna return the result. So this is a very basic pattern of how to calculate the longest path of a graph by using DFS. So from beginning it is a 1, we find 1 node, and then we're gonna check all other node. Yeah, and it's gonna be the longest of all other node. So this is the result, and we're gonna compare all other nodes, but we're gonna return the longest. So finally we're gonna return the longest, which is gonna be the result. Yeah. Now let me just run it to have a check. Now as you can see it works. Now let me just submit it to prove that it works. Yeah, now as you can see it works, although it is a little bit slower, but I think this is okay. Yeah, because basically this is a difficult problem. Now, as we can see, we solved it in a quite easy way, because this kind of coding is not so difficult. It is just a medium problem. And for this kind of coding, it's like an easy problem. Yeah. Now, the hard problem becomes an easy problem, and it is easy to solve and easy to remember. Thank you for watching. See you next time.